So we're going to pick back up on this. We've already done the introduction module, done a review on that, and now we're going to kind of go over the module 1, cloud concept overview. And I see some of you guys have already completed it, and you're doing a great job. You're getting high scores, which means that you have a good understanding of some of the basic concepts of it, and I'm really happy to see that. So let's go ahead and go over. So the way I'm going to be kind of doing this as we go through the modules, because everything's being done virtually and it's a different kind of feel. We'll go over the videos, and as I have any additional input or insight or experience, I'll be sharing that in addition to the videos, just to try to make it as good of an experience as possible. So let's go ahead and get started with the introduction video.
Hello, and welcome to AWS Cloud Foundations Module 1. This is called Cloud Concepts Overview. This module addresses the following topics: Introduction to Cloud Computing, Advantages of Cloud Computing, an Introduction to Amazon Web Services, and the AWS Cloud Adoption Framework. In addition to this video, there's going to be a knowledge check that will be used to test your understanding the key concepts that are covered in the module. After completing this module, you should be able to, number 1, define the different types of cloud computing. Number 2, describe the 6 advantages of cloud computing. Recognize the main AWS service categories and the core services. And finally, review the AWS Cloud Adoption Framework. We're ready. Let's get started. Hello, and welcome. This video will cover an introduction to cloud computing. What does cloud computing mean to you? Take a moment, think what cloud computing means to you, and write a short sentence. Cloud computing is the on-demand delivery of compute power, database, storage, applications, and other IT resources via the internet with pay-as-you-go pricing. These resources run on server computers that are located in large data centers in different locations around the world. When you use a cloud service provider like AWS, you are using the computers owned by that service provider. These resources can be used together like building blocks to manufacture solutions that will help you meet your business goals and satisfy technology requirements. Cloud computing enables you to stop thinking of your infrastructure as hardware. Instead, think of it as software. But what does that mean? In the traditional compute model, infrastructure is thought of as hardware. Hardware solutions are physical, which means they require space, staff to maintain it, physical security, planning, and a capital expense. In addition to significant upfront investments, another prohibitive aspect of traditional computing is the long hardware procurement cycle that involves acquiring, provisioning, and maintaining on-premises infrastructure. With a hardware solution, you must ask if there's enough resource capacity or sufficient storage to meet your needs. And you provision capacity guessing theoretical maximum peaks. If you don't meet your projected maximum peak, then you pay for expensive resources that stay idle and don't render you any benefit. If you exceed your projected maximum peak, then you don't have sufficient capacity to meet your needs, and your customers do not receive the service that they desire. If your needs change, then you must spend the time, effort, and money required to implement a new solution. For example, if you wanted to provision a new website, you will have to go out and buy the hardware, rack, and stack it, put it in a data center, then manage it, or have someone else manage it. This approach is very expensive and time-consuming.
Okay, so I'm going to back up just a tad. There we go. So he did a great job explaining it, and I'm just going to just kind of add on to it what the traditional model is. Well, the model that's been used in the past in regards to providing any kind of computing and server maintenance or support. So I know some of you guys had mentioned a concern of different kind, if you didn't have the background or the experience coming into this program to succeed. And everybody's going to have different kind of experience levels, and education levels coming into it. My background is a bachelor's in IT and a master's in information systems management. But then my career path just did not take away that I actually was able to use that skill sets that I acquired during my degrees. It just went a different way. And so, you don't use it, you lose it, kind of, so to speak. But what's been nice about, learning about AWS and cloud computing and everything else is because it's basically like everything that I learned in my IT degree, and looking at servers and hardware and maintenance and all that stuff. And I'm remembering some of it because all the cloud is the server, the hardware, everything else. Amazon takes care of it. It's in it's a completely different building or buildings, and they responsible for everything. So all the hardware that they talk about, now it's Amazon's problem. We don't even have to look at it. We just have to, using software, AWS software, whether it's the console or the CLI, which I don't think they've gotten into yet and may not get to on this. But let's just go with the console, which is their website. We can navigate and we can, procure services. We can set things up. We can do all of that stuff that we would have traditionally done in a typical, traditionally, actually having the rack and the servers and everything on premises. So, and when you do that, when you have the rack and the servers and everything on premise, there's so many things that go into it. For one, if you're on premise, if it's on site in your organization or your business, you have to have the space for it. You have to have people who know what to do with it if something should happen, or to maintain it, do regular maintenance on it, updates, setting it up, whatever. You need to have some security, physical security, just to make sure that nobody, tries to steal it, or does anything malicious to it. And then that also includes any kind of firewall. So the security aspect can be from actually physically accessing the servers to remotely accessing the servers. The planning, anything that you need to do to plan, capital expenses. Servers are really, really expensive. The maintenance, the infrastructure, the upkeep, the environmental concerns, like, making sure it's cool enough, making sure, all of the stuff that I don't even remember anymore, like the fire. If there's a fire, that has to have certain kind of chemicals, just regular water. Things, all of that you have to worry about, and that all costs money. And but you don't have to worry about. That was what you did in the traditional computing model. You have a long hardware procurement cycle. You have to require you to provision capacity by guessing the theoretical maximum peaks. And what that basically means is scalability. Scalability is going to be something you're going to be hearing a lot when it comes to AWS, because it's one of such a huge selling point of why to use cloud computing. And what that means is, like I think he mentioned in there, if you're not using services, if you're not using the computing power because there's not the demand for the computing power on whatever it is that you're created, then it's just sitting idle. And you bought computing power that you're not using. But you also don't want to, purchase too low of computing power, because if there's a higher demand for whatever your website or app is, then it's going to have a severe lag, and people and your end customers are not going to have a good experience. So you don't want that either. And we have to, it's like a guessing game almost, that you have to, if you're going to purchase the hardware if you're going to actually purchase the hardware itself, it's almost a guessing game. It's like, how much do you need? And you don't want too little, because you want to be able to be sure that you provide your end customer a really good experience. But you don't want to be too much, because of the fact that it costs money, and if it's not going to be used, it's just wasted dollars. In addition to requiring the space and everything for your on-site premise, your on-site servers, the other thing to think about is, just for security and reliability factors, is oftentimes, and many organizations will require that you to have another place where the information is replicated. That's just to ensure that all the information stays secure and available should one site go down. For example, Whenever I was getting my bachelor's at the University of Rio Grande in IT, I remember looking at their server room. That was part of the classroom. And University of Rio Grande is based in Rio Grande, Ohio, and there where they had the replicate or the duplicate for their servers, it was in Columbus, which is about 2.5 hours away, because it was considered far enough where if any kind of disaster affected Rio Grande, it would not necessarily affect Columbus in theory. So, but you have to worry about that. Then you have to pay for all of that, for that offsite location and housing and maintenance and everything else. So that's the traditional mindset of the traditional computing model. So let's go ahead and go on.
Have someone else manage it. This approach is very expensive and time consuming. By contrast, cloud computing enables you to think of your infrastructure as software. Software solutions are flexible. It means that you can select cloud services that best match your needs, provision them, and terminate their use based on your demand. You also pay only for what you use, when you use it. You can scale resources up and down in an automated fashion as a way to expand and contract your deployment in order to meet your customer demand. With the cloud computing model, you can treat resources as temporary and disposable. The flexibility that cloud computing offers allows businesses to implement new solutions quickly with very low upfront cost. Compared to hardware solutions, software solutions can change much more quickly, easily, and cost-effectively. Cloud computing helps developers and IT departments avoid undifferentiated heavy lifting work like procurement, maintenance, and capacity planning. They also enable you to focus on what matters most, which is your business and its improvement and evolution. As cloud computing has grown in popularity, several different service models and deployment strategies have emerged. This will help you meet your specific needs for different users. Each type of cloud service model and deployment strategy provides you with a different level of control, a different level of flexibility, and management. Understanding these differences between these cloud service models and deployment strategies can help you decide what set of services is right for your needs. There are three main cloud service models: infrastructure as a service, platform as a service, and software as a service. Each model represents a different part of the cloud computing stack and gives you a different level of control over your IT resources. First, infrastructure as a service are the basic building blocks for your cloud information technology and typically provide you with access to networking features, computers, whether it's virtual or dedicated, and provide storage space. Infrastructure as a service provides you with the highest level of flexibility and control over your IT resources. It is most similar to your existing implementation that many IT departments and developers are familiar with today. Platform as a service removes the need for you to manage the underlying infrastructure. Usually this relates to the hardware and operating system. It does it through automation. Focus on the deployment and management of your applications as opposed to the provisioning. Software as a service provides you with a complete product that is run and managed by the service provider. In most cases, software as a service refers to end user applications. With software as a service, you do not have to think about how the service is maintained or how the underlying infrastructure is managed. You only need to think about how you will use that particular piece of software. A common example of software as a service is a web-based email application where you can send and receive email without having to manage the server, the email product, or maintaining the operating system in that email system. There are three main cloud computing deployment models. Each of these represent the cloud environment that your applications can be deployed in. A cloud-based application is fully deployed in the cloud in the all-in-the-cloud type of implementation. All parts of your application will be running in the cloud. Applications in the cloud have either been created in the cloud or have been migrated from an existing infrastructure. To take advantages of the benefits of cloud computing, your applications then can be built on low-level infrastructure pieces, or you can use higher-level services that provide abstraction from the management, architecting, and scaling requirements of your core infrastructure. In a hybrid implementation, the deployment is such a way that to connect your existing infrastructure and applications to a cloud-based resources. They're not located in the cloud, They're located in your physical facilities. The most common of this hybrid deployment is between cloud and existing on-premises. This extends and grows your implementation while connecting cloud resources to your internal systems. Finally, on-premises. Deploying resources on-premises use virtualization and resource management tools, sometimes called private cloud. While on-premises deployment does not provide many of the benefits of cloud computing, it is sometimes sought for its ability to provide dedicated resources. In most cases, the deployment model is the same as a legacy information technology infrastructure, while using application management and virtualization technologies to try and increase resource utilization. There are many similarities between AWS and a traditional IT implementation. First, AWS security groups and network access control lists are similar to firewalls. AWS identity and access management is similar to user provisioning and access control list. Elastic load balancing and Amazon Virtual Private Cloud represent your cloud networking infrastructure, which compares to routers, network pipelines, and switches. Amazon Machine Images are used to initialize Amazon EC2 instances. They're similar to your on-premise virtual servers. Amazon Elastic Block Store represents a hard disk that attaches to your virtual machines and is equivalent to a direct attached storage. Amazon Elastic File System also attaches to your virtual machines, but it represents a traditional storage area network. Amazon Simple Storage Service, or S3, provides the ability for you to store files using the internet and is similar to network-attached storage. Finally, Amazon Relational Database Service is the equivalent to your physical relational database management system. So pretty much everything you will want to do with a traditional data center is available with AWS. Thanks for watching. We'll see you in the next video where you will learn about the advantages of cloud computing.
Okay, so let's go on to the next one.
Hello and welcome. This video will cover the advantages of cloud computing. Why are so many companies interested in moving to the cloud? This section presents 6 advantages of cloud computing. Advantage number 1, trade capital expense for variable expense. Capital expenses, or CapEx, are funds that a company uses to acquire, upgrade, and maintain physical assets, such as property, industrial buildings, or equipment. You must pay for everything in the data center, whether you use it or not. By contrast, a variable cost is a cost that you can easily alter or avoid by using cloud computing. Instead of investing heavily in data centers and servers before you know how you will use them, you can pay only when you consume resources and pay only for the amount that you consume. Thus, you save money on technology. It also enables you to adapt to new applications with as much space as you need in minutes, instead of weeks or days. Maintenance is reduced, so you can focus more on your needs and the needs of your business. Advantage number 2, benefit from massive economies of scale. By using cloud computing, you can achieve a lower variable cost than you can get on your very own. Because usage from hundreds of thousands of customers is added up in the cloud, providers such as AWS can achieve higher economies of scale. That translates into lower pay-as-you-go prices to you. Advantage number 3, stop guessing capacity. Eliminating guessing about your infrastructure capacity needs. When you make decisions about capacity before you deploy an application, you often either have expensive idle resources or deal with limited capacity. With cloud computing, these problems go away. You can access as much or as little as you need and scale up and down as required with only a few minutes notice. Advantage number 4, increase speed and agility. In a cloud computing environment, new information technology resources are only a click away, which means that you reduce the time it takes to make those resources available to your developers from weeks to just minutes. The result is a dramatic increase in agility for the organization because the cost and time that it takes to experiment and develop are significantly lower. Advantage number 5, stop spending money on running and maintaining data centers. Focus on projects that differentiate your business instead of focusing on the infrastructure. Cloud computing enables you to focus on your own customers instead of the manual racking, stacking, and powering of servers. Advantage number 6, go global in minutes. You can deploy your application in multiple AWS regions around the world with just a few clicks. As a result, you can provide lower latency and a better experience for your customers, simply and at a minimal cost. Thanks for watching. We'll see you in the next video.
Okay. So one of the things that I like to do in my class is use case studies, because I think case studies really kind of cement the ideas of what in theory AWS can do and what in actuality it has done. So one of my favorite case studies is Lyft, the rideshare service. So this is a case study from 2016, but it's still just one that was stuck in my mind. So, as you probably know, Lyft is a rideshare company in the United States, more than 200 cities. This, again, was in 2016. And Lyft uses AWS to move faster as a company and manage its exponential growth, leveraging AWS products to support more than 100 microservices that enhance every element of the customer's experience. Because you got to remember, whatever your business or service is, your end customer is what's going to help make it succeed or fail miserably. Launch lifted on AWS and dramatically expanded its use of AWS products as they became available. It uses products such as auto scaling to manage up to 8 times more riders during peak times. And again, that's where talking about the scalability factor of your increased usage, and what AWS can do is automatically scale up. So I think he makes a reference how in comparison between Friday night versus Sunday morning. Friday night, people have been drinking and at the bars and whatnot, so they're probably using the services a lot more, so they're able to meet that demand. Or as opposed to Sunday morning, most likely not using their services, and it scales down, and they only pay for what they actually use. They use Redshift to gain customer insights. Redshift is a data warehouse. It uses Kinesis, which is data streaming, something to do with data streaming, and leverages the scalability of Amazon DynamoDB, which is a NoSQL database for multiple data stores. It includes ride tracking systems that include GPS coordinates for all rides. So there's IoT. I don't know if they mentioned IoT in this, but there is some IoT components as well. So let's go ahead and watch this. This is...
Hi, excited to be here. My name is Chris Lambert. I'm the Chief Technology Officer with Lyft, and I'd like to tell you a little bit about our journey from being a small, scrappy startup in San Francisco to now being the fastest growing provider of on-demand transportation here in the US. Along the way, I'll highlight how Amazon Web Services has helped us move faster as a company and scale our marketplace more efficiently. I'll start back in 2012. When Lyft launched, it was a really simple service for rides on demand. You could pull out your phone, hit a button, and within a few minutes, a driver would show up and take you anywhere you wanted to go. When we launched, it was just 3 servers, all running in US East in different availability zones. And our very first Lyft ride was completed on May 31st, 2012. And it's funny because the 2 engineers that had built the first prototype weren't really sure how it was going to work in production. Would the state machine work? Would the ride actually happen? So when they were tailing logs, and when they saw the ride drop off event hit production, they're like, well, maybe it worked. We actually don't know. So they called the driver and they said, hey, this is Lyft. Did you drop Daryl off? And the driver's like, yeah, I just dropped him off. He's not in the car. And they're like, okay, great, thanks. And I don't know who was more surprised, like the engineers that this works, or the driver that they're going to get a phone call after every single drop off asking if they dropped him off. But it was really early on. It was 3 weeks from idea to actual launch. And we were 100% on AWS at the time. The only difference now, we're still 100% on AWS, but we're taking advantage of many more Amazon technologies.
Okay, try and pause. I don't know if you captured that. Let me rewind that.
That's at the time. The only difference now, we're still 100% on AWS.
Oh, not quite
but we're
there
taking
yet.
advantage. And it was 3 weeks from idea to actual launch, except they dropped him off. But it was really early on. It was 3 weeks from idea to actual launch.
Okay, so make sure you caught that. 3 weeks from idea to actual launch. Okay, that's it. it was rough in the beginning, but everything is. But 3 weeks from them, I think it's him and two other fellows, if I remember correctly. He talks a little bit more about it. From the idea, let's create a rideshare. I don't remember which one's first, Uber or Lyft, but the idea to actuality. And that is one of the huge benefits and advantages of AWS, and that it can provide is because 3 weeks from idea to launch. Uh, if you had to do everything like on premise, if you had to purchase all the equipment and everything, for one, that's a lot of money to come up with. If you're going to use investors, that's a lot of time and all the headaches and hassles that can come from having to acquiring investors. But and he'll explain more about the advantages of using AWS. But I just want to make sure you caught that 3 weeks from idea to launch.
And we were 100% on AWS at the time. The only difference now, we're still 100% on AWS, but we're taking advantage of many more Amazon technologies besides EC2. So fast forward a year, we had our first big milestone as a company, 1 million rides completed. San Francisco was going like crazy. We had launched Los Angeles and a few other cities, and things were just taking off. You can get an idea of what that growth looks like with just looking at the first 15 months here with our path to 1 million rides. And this has continued for the last 4 years. However, that exponential growth is great, but it didn't prepare us for what was about to happen. We decided to launch 24 additional cities in 24 hours. This was a huge effort across the company, marketing, operations, engineering. And of course, the engineering approach to this problem was, well, let's get out of the way. Let's enable auto-scaling. Let's make it so whatever happens in the real world, whether it's a rainstorm or the Super Bowl, anything that happens, we can handle. Our infrastructure should just scale up seamlessly. So we rolled out auto-scaling just in time for our 24-city launch, went off without a hitch. We doubled our footprint overnight. And you can just see how significant this is. That last little tick there was all in 24 hours. And that was pretty massive growth for us as a company. And auto-scaling works great for your application tier, but there's one more benefit you get from it, which is that we do 8 times as many rides at peak on a Saturday night as we're doing on a Sunday morning. So auto-scaling also allows us to scale down our infrastructure to save a significant amount on infrastructure costs when we don't need to pay for it. So I mentioned auto-scaling application tier, that's fantastic. But what about Datastore? One of our biggest data stores was outgrowing its current technology, and we decided to move it to Dynamo. This was the ride location tracking system. So every GPS location for all of our rides was stored in this system. We moved it over to Dynamo, and it was so simple to scale up. You had 2 knobs, one for write capacity, one for read capacity. You didn't have to carry a pager. You didn't have to deal with chunk migrations. It just worked really, really well. And we've since moved many of our other data stores over to Dynamo as well. The single biggest launch in Lyft's history came a few months later. This was Liftline. Liftline is our shared ride service. What that means is if 2 passengers have a very similar route and they're requesting a ride within a few minutes of each other, we can give them the option to share that ride with the other passenger for a significant savings, often up to 50% off their ride. This changed our business significantly, and it was possible because of some analysis that our data science team did with our Amazon Redshift data warehouse. So we had all of our data in Redshift, and they basically would run simulations every few months looking at what would be possible in terms of new transportation modes. And they realized that 90% of our rides at peak times were co-similar enough to another ride where we could actually build this shared rides product. So as soon as this was the case, we kicked off a few engineering teams, and we were able to launch Liftline in August 2014. And it's been the biggest driver of growth in our biggest markets, and is the future of the company.
Okay, so talking about Redshift and data. I'm currently teaching a database class right now, which talks a lot about analytics and data in the warehouse and kinesis, streaming, and everything. But in this case, he was talking about Redshift, and data creates information. I find data so interesting, and because of the things that it can tell you the things that can help you understand. So what they did, because their engineers looking at the data repetitively over a period of time, they saw, as he said, about 90% of their customers could, if they were in a similar enough geographical region where they could potentially, share the cab, share the Lyft, so to speak, and save them some money. So that was not be a service that they most likely would not have seen that they could offer to the benefit of them as a company and their end customers if they did not take the time to analyze the data and utilize the resources that AWS provides with Redshift and whichever other services that they were utilizing.
Fast forward a year, we now have a proliferation of many different microservices, all serving production traffic at Lyft, and we wanted a really easy, simple way for them to communicate with each other. And we built this PubSub system on top of Amazon Kinesis that funnels every single production event through the system. So every time you open the app, every time you request a ride, every time you move, the car actually moves. It goes through this Kinesis pipeline, and any other service at Lyft can subscribe for events. They can say, I care about credit card ad. So our fraud system can say, let me know anytime someone adds a new payment method, removes a payment method, I want to rescore that user's fraud risk. Our dynamic pricing system can say, let me know every time a driver changes neighborhoods, because I want to make sure I'm pricing these rides as accurately as possible. This is a really complex infrastructure with a lot of moving parts, and it's all simple for us because of Kinesis. October 2015 was 3 years after we launched, huge milestone, $1 billion annual run rate. Business is just bigger than it's ever been. To give you a sense of scale, right now there are over 10,000 people in Lyft rides across the country. For them, they're getting to work, seeing friends, seeing family, relying on Lyft for their income. Downtime is not an option for us, and we've been able to depend on AWS to provide the level of reliability and availability that our users have come to expect from Lyft. So I talked a little bit about the services we have in production. On March 2016, we added our 100th microservice. These are all, again, managed independently, scaled automatically, and these services are collectively serving over 1 million requests per second. This is what powers Lyft. Every time you request a ride, you're not just hitting a single service, you're probably hitting 10 or 20 different services that are working together to make that ride go as smooth as possible. And just to give you a little bit of insight, this is the set of Amazon services we're using today in production. These are all taking real traffic. Teams have depended on them, and they've all worked really, really well for us over the last 4 years. So last big announcement, I'm excited to say, as of last month, we completed 14 million rides. Just for context, it took us 15 months to get to our first million, and in the last month, we've done 14 times that alone.
15 months. They kept utilizing more and more AWS services as there was a need for it. And from 15 months, less than 2 years, they went from 1 million to 14 million rides. Okay? Just think about
it. It's our biggest month ever by pretty much any metric. We're incredibly excited to be here. We're hiring in San Francisco, Seattle. Love to have you help come join, build the future of Lyft, and continue to use AWS whenever it makes sense for our business. So thank you for having me.
So that is like one of my favorite stories because there are just so many things that they did have with the one idea to creation in 3 weeks, from 15 months, from 1 million to 14 million. All of those things that if they had to do it the more traditional route of buying the hardware and the infrastructure and everything else, and the maintenance that would have, and the headaches that would have come with it. Even if they had all the expenses covered, if the headaches of trying to scale up and figuring out all these different things, like with all the moving parts that he was talking about that they were able to do with Kinesis, it probably never would have happened and probably never would have succeeded. Okay, so I think we'll go ahead and call it at this point right here at the end of section 2 on this particular video. I don't want these individual videos to be so long because I know it can be not the most exciting thing to learn by video, but it is the reality. Even if it's not COVID, time. It's the reality of the field. And you have to kind of figure out what works for you. You don't want it to be such a miserable experience you don't continue. But you want to make sure that you're still, able to retain information and that you're still learning and you're just not like a mindless zombie going through the steps. But hopefully this is, between the combination of watching these module videos and any insights that I can provide or any other resources that can help develop a better understanding of it is going to be a benefit to you. In this case, the Lyft case study. So that's it for this video. And if you have any questions, please let me know. Thank you.